Hello and welcome to KLM Institute.
Have you ever wondered if we could harness the power of lightning to meet our energy needs? Imagine capturing a lightning bolt, a single strike that carries up to 1 billion joules of energy, enough to power a whole household for a month. The potential for lightning to revolutionize energy generation seems incredible, right? But, despite all the excitement, the dream of harvesting lightning energy has proven to be more of a fantasy than a practical reality. Let's take a closer look at why this is so. Lightning is a sudden electrical discharge during a thunderstorm, created by the buildup of electrical charges within clouds. The energy released in a lightning bolt is enormous, with temperatures reaching up to 27,000 degrees Celsius, about 6 times hotter than the surface of the sun. This intense energy, though, is incredibly difficult to capture and store. One of the biggest challenges is lightning's unpredictability. There are millions of lightning strikes around the world every day, but they happen randomly, with no way to predict exactly where and when they will strike. This makes it impossible to set up reliable systems to capture and store the energy consistently. Another major hurdle is the nature of lightning itself. A single bolt carries an immense amount of energy in just a fraction of a second. The voltage can reach several hundred million volts, and the current can be tens of thousands of amperes, making it extremely difficult to capture this energy safely. Additionally, lightning is only around for a split second, so storing it becomes a complicated task. Creating systems to withstand the massive heat, electromagnetic fields, and mechanical stresses that come with lightning is no easy feat. The infrastructure would need to be incredibly strong to avoid being destroyed by the intense forces. And once the energy is captured, converting it into a usable form is another challenge. The high-voltage direct current produced by lightning would need to be converted into alternating current for use in homes and businesses, a process that would require massive storage systems. Over the years, there have been attempts to harness lightning's power, but none have been successful. In 2007, a company called Alternative Energy Holdings tried to build a system to capture lightning. The design included a tall structure with grounding wires and capacitors to store the energy. However, despite their ambitious plans, the project ultimately failed. As CEO Donald Gillespie admitted, "Quite frankly, we just couldn't make it work." Even centuries ago, great minds like Benjamin Franklin tried to understand lightning's power. His famous kite experiment showed that lightning was electrical, but the technology at the time wasn't advanced enough to capture or store that energy effectively. So, while the idea of using lightning as an energy source is fascinating, the technical challenges are simply too great for it to be a viable solution right now. Rather than focusing on the unpredictable and dangerous energy of lightning, scientists and engineers are turning their attention to more reliable renewable energy sources, such as solar and wind power, which offer a more practical and sustainable solution for the future. Thank you for joining us at KLM Institute. Stay tuned for more insights into the world of science and technology.